Hello and welcome back to the RedMars Podcast. I'm AstroJake, your guide to the incredible universe of space exploration, and today we're focusing on one of humanity's greatest engineering achievements, space stations. So picture this, a massive structure floating hundreds of kilometers above Earth's surface, housing humans who are working, eating, and even exercising, all while conducting groundbreaking research. That's a space station, and it represents the pinnacle of innovation, teamwork, and ambition. But space stations are more than just floating labs. They're humanity's foothold in space. They're a testbed for technologies we'll need to colonize the moon, explore Mars, and travel even farther into the cosmos. In this episode, we'll dive into what space stations are, how they have come to be, and the engineering marvels that make them possible. We'll also explore the partnerships that build these orbital outposts, the materials that keep the astronauts safe, and the technologies that power these floating homes. Plus, we'll take a look at the future of space stations, imagine inflatable habitats, and commercial hubs in orbit. By the end of this episode, you'll have the deep appreciation for the ingenuity and efforts that go into these incredible structures. So let's get started, and this one is going to be a longer episode than usual because there's so much to cover. So what exactly is a space station? Unlike traditional spacecraft designed for short missions, a space station is built for long-term habitation and research. These structures orbit Earth, or in the future, other celestial bodies, and serve as hubs for science, technology, and international cooperation. Space stations are modular by design, meaning they're made up of individual sections that are launched separately and then assembled in space. Each module serves a specific purpose: laboratories for research, living quarters for astronauts, and docking ports for visiting spacecraft. But what makes space stations so special is a role as a bridge between Earth and the cosmos. They allow us to study microgravity's effects on the human body, test new technologies in space, and even monitor Earth's environment. Think of them as humanity's floating science labs and observation decks, giving us a front row seat to the universe. Now, let's start with a brief history of space stations. So the history of space stations is a testament to human innovation and resilience. Let's start with the Soviet Union's Salyut-1, launched in 1971. It was a single-module space station, and though its mission was short, it proved that humans could live and work in space for weeks at a time. NASA entered the scene with Skylab back in 1973. This space station was groundbreaking, featuring solar observatory, science lab, and even living quarters for astronauts. Skylab missions provided valuable data about the effects of long-duration spaceflight. Then came the Soviet Union's Mir in 1986. Mir was the first modular space station and a hub for international collaboration. It hosted astronauts from around the world and set records for long-duration spaceflights. Finally, we have the International Space Station, the ISS. It was launched back in 1998. The ISS is a joint effort involving 15 countries, including those from the United States, Russia, Japan, members of the European Space Agency, and more. With over 30 modules and a size larger than a football field, the ISS represents the pinnacle of human ingenuity and global teamwork. So, how do these space stations connect, and what exactly is that global partnership? Well, one of the coolest things about space stations, like the ISS, is how they're built and connected. The ISS is modular, meaning section or module is designed to work independently and then be joined together in orbit. This approach allows countries to contribute their own unique modules, from laboratories to living quarters. For example, the US Destiny Laboratory is the ISS's main science lab. The European Columbus module focuses on material science and biology. Then there's the Japanese Kibo module. It includes a platform for experiments exposed to the vacuum of space. These modules are connected using docking ports and robotic arms, like the Canadian Canadarm2, which precisely maneuvers them into place. Global partnerships make this possible. Countries pool resources, share expertise, and coordinate launch schedules. However, geopolitical tensions can sometimes complicate things, as seen in recent discussions about Russia's plan to build their own space station. So, with all this joint collaboration, what about training and simulation? Well, astronauts don't just wake up one day and head to space. They train for years to live and work on the space station. This preparation happens at specialized facilities around the world. NASA's Neutral Buoyancy Laboratory, NBL, in Texas is a massive pool where astronauts practice spacewalks in simulated microgravity. They wear full spacesuits and work underwater in mock-ups of the space station modules. In Russia, the Gagarin Cosmonaut Training Center prepares astronauts for every aspect of spaceflight, from emergency drills to docking maneuvers. And in Europe, the ESA, European Space Agency, uses virtual reality and centrifuges to simulate weightlessness and the forces of launch and re-entry. These simulations are essential for teaching astronauts how to handle emergencies, repair systems, and perform experiments. So what about materials and the safety of the astronauts? Well, space is an incredibly hostile environment, and every element of a space station must be designed to withstand its extremes. Let's unpack some of the biggest challenges and the ingenious engineering solutions that keep our astronauts safe. So, first we'll talk about the temperature extremes. In space, temperatures can vary dramatically depending on whether a station is in sunlight or a shadow. On the sunlit side, temperatures can soar to 120 degrees Celsius, that's 248 degrees Fahrenheit, while on the shadowed side, you can see plummeted temperatures down to negative 100 degrees Celsius or negative 148 degrees Fahrenheit. That's pretty hot and pretty cold. So picture that the next time you're on a hot sunny day on a Florida beach or a freezing cold day up in Montana. It's not so bad when you think about it in the end. So to manage this, space stations like the ISS rely on several things. One of these things is thermal control systems, TCS. These regulate the station's temperature using a combination of insulation and active systems. Multi-layer insulation, MLI. This silvery, blanket-like material wraps the station's modules to minimize heat transfer. It's made of multiple thin layers of plastic and aluminum, which reflect solar radiation and keep internal temperatures stable. If you've ever seen pictures of satellites or maybe the space station itself, you'll typically see this material, and that multi-layer insulation, MLI, is very, very useful in these situations and why you see it such widely used. Now, radiators. Radiators are large panels located outside the station, and they dissipate excess heat generated by onboard systems. This ensures that the station doesn't overheat. Now let's go back to radiation protection. Unlike Earth, which is protected by its atmosphere and magnetic field, space stations are exposed to high levels of cosmic radiation and solar particles. This exposure increases the risk of cancer, cataracts, and other health issues for astronauts. So to mitigate these risks, the ISS uses radiation shielding made from aluminum alloys and polyethylene, which are excellent at absorbing high-energy particles. Water tanks are strategically placed around living quarters, since water is naturally a radiation shield. In case of a solar flare, astronauts are instructed to shelter in heavily shielded areas, like the station's service module, which has additional protection layers. Micrometeoroids and orbital debris. Space debris and micrometeoroids traveling at speeds of up to 28,000 kilometers an hour or 17,500 miles per hour. These speeds may sound familiar because we previously mentioned them on one of our earlier episodes about orbits, where this is the speed for, say, a LEO, low Earth orbit. You need to travel at those speeds to avoid falling and plummeting back to Earth. So, imagine a micrometeoroid traveling at these speeds, micro meaning they're very small, but they pose a significant threat to the integrity of a space station. Even a small particle can cause catastrophic damage. So what solution is there? Well, Whipple shields. What is a Whipple shield? Well, these shields consist of a thin outer layer that breaks apart incoming debris. So, followed by layers of tougher material, these absorb the energy of the fragments. So for example, the ISS modules are equipped with shields made of Kevlar, Nextel, and aluminum to provide maximum protection. In addition, collision avoidance maneuvers are sometimes conducted using the station's thrusters to steer clear of larger pieces of debris that is tracked here on Earth. So they give enough warning for some of these larger items that are tracked to know when to make those maneuvers. Now for the smaller items, it's a bit more difficult, and that's why we have to have these special Whipple shields to protect us. So what about the structural integrity and lightweight design? Well, the materials used to construct a space station, they must be strong to endure the stresses of a launch, and the rigors of space and being as lightweight as possible to minimize launch costs. So you kind of have a balancing act here. How do we keep something light enough that we can, spend the least amount of money to get it into space, but at the same time use material strong enough to protect yourself from all the hazards that exist in orbit and beyond. So with that, aluminum lithium alloys are used. These are commonly used because they are lightweight, corrosion resistant, and they are highly durable. We also use carbon fiber composites for elements requiring extra strength with minimal weight, such as trusses or external platforms. Now there's also titanium. Titanium is used in certain high-stress components due to its superior strength-to-weight ratio. Now titanium is also super expensive, so it is used only where it's needed. Now, life support systems. We talked a little bit about this in a previous episode as well, and about a system called ECLSS, which is the Environmental Control and Life Support System. Now, this is a marvel of engineering, and it is responsible for maintaining, as we mentioned previously, oxygen levels, generated through electrolysis, which split water into oxygen and hydrogen, carbon dioxide removal. This is achieved using systems like CO2 scrubbers that absorb excess CO2 using chemical reactions with substances like lithium hydroxide and zeolites. Humidity control. Excess moisture from breathing, sweating, and other activities is removed from the air to prevent mold and maintain comfort. Fire safety and air contamination. Now, we didn't talk about this one previously, so we'll touch on it here. So fires in space are a worst-case scenario. Without gravity, flames behave unpredictably, and extinguishing them is a bit more complex. I don't know if you've ever seen a picture of a lit candle on the space station, but if you haven't, definitely go take a look. It won't look quite as you expect. So, to prevent and manage fires, there's several things that we do in space. So we use fire-resistant materials. So interior components and clothing are made from flame-retardant fabrics. We use air filters to continuously remove particulates and volatile organic compounds, VOCs, to ensure air quality. And fire suppression systems. We use carbon dioxide or water mist extinguishers designed specifically for microgravity. Now, emergency escape and safety protocols. What if nothing works and when all else fails, you need to evacuate and get out? So even with all these precautions, emergencies can still happen, so you need a plan. The ISS is equipped with multiple Crew Dragon and Soyuz spacecraft, which serve as lifeboats for quick evacuation. These spacecraft are always kept in a state of readiness and can be used to return astronauts to Earth within hours. Think of it as a big go bag for everyone in space to get back home safely and sound in little to no time. So, what are some of the cutting-edge innovations in safety materials? Well, the future of materials science is offering exciting new possibilities for space station safety. Now, we have things such as aerogels. Aerogels are super cool. Definitely go look up images of this and see what those look like. There's some cool videos of cutting up an aerogel and handing it around, and it's just really fascinating to see. It looks like it's some sci-fi thing, but as mentioned before, things are only sci-fi till they're not. So aerogels are ultralight materials with excellent thermal insulation properties and are being tested for use in future habitats. Self-healing polymers, materials that can automatically repair small punctures caused by micrometeoroids. This reduces the need for manual repairs. Transparent aluminum, ALON, a futuristic material that's incredibly strong and could be used for viewports and other components, requiring both durability and transparency. So by combining all these advanced materials and systems, space stations like the ISS create a safe and livable environment in one of the most dangerous places imaginable. Every detail from the insulation on the walls to the algorithms controlling life support systems is a testament to human ingenuity and determination. Without these safety measures, our dreams of living and working in space would remain just that, dreams. But thanks to these incredible technologies, we're not just surviving in space, we're actually thriving, and plan to do so even more in the future. So, to get to space, we mentioned you have to launch these modules into orbit and then assemble them, but they also need to dock. So what about these docking systems and spacecraft integration, and how do they work? Well, docking spacecraft to a space station is a complex process that requires pinpoint precision. Modern spacecraft use a combination of thrusters, sensors, and algorithms to approach and attach to the station. The International Docking System Standard, IDSS, ensures compatibility between spacecraft from different countries. For example, SpaceX's Crew Dragon and Boeing's Starliner, we won't talk about that, both use this standard, making international collaboration much easier. That is why you can have the Starliner or Crew Dragon, even the Soyuz, attached to the International Space Station and bring astronauts from varying countries. So, robotic arms like the Canadarm can also play a key role that can capture cargo ships and guide them into their docking ports as well, in the event of maybe a failure. So, current space stations, they orbit in LEO. So the ISS is the crown jewel of space stations today, but it's not alone. China's Tiangong station is rapidly growing, and it features modules for research and living quarters. Both these stations orbit between 300 to 500 kilometers above Earth, where they balance microgravity with accessibility for resupply missions. So LEO's a great place for this because you don't have to go oh so high to bring resupplies, but it also provides a good enough balance for an orbit that allows them to burn excess amount of fuel to keep them up there. So there is a bit of an atmosphere still, even at 300 to 500 kilometers above Earth, that requires a little push every once in a while just to keep them going. So what does the future of space stations look like? Well, this is a very fascinating topic, so we're going to go a little bit more into detail on some of these and spend some time talking about each of the individual contenders. So the future of space stations is one of the most exciting frontiers in space exploration. With advances in technology and growing interest in commercial space activities, we're seeing concepts that could redefine how humans live and work in orbit. So let's dive a bit deeper into two of the most innovative projects. That's Orbital Reef and expandable habitats like Bigelow Aerospace B330. That's their living habitat that they're working on right now. So we'll also touch on Lunar Gateway and some of the other developments that are also exciting, but we'll focus on the first two here. So Orbital Reef, a commercial space hub. Orbital Reef is an ambitious project spearheaded by Blue Origin and Sierra Space. I was about to say Sierra Nevada, but they go by Sierra Space now. I gotta correct myself on that sometimes. So with collaboration from other industry leaders, it's not just the two of them, but the main contenders here are Blue Origin and Sierra Space. It aims to be a mixed-use space station designed for commercial, research, and tourism purposes. Think of it as a business park, but in space. Super cool. So what are some of the design features here? So Orbital Reef is designed with a modular architecture, allowing for easy expansion. The station will feature advanced life support systems, spacious modules, and large windows for stunning views of Earth. And this caters to both researchers and space tourists. So what are the use cases here? Well, research is one of the first ones. So scientists can conduct experiments in microgravity across various fields such as pharmaceuticals, material science, and biology. Next, we have tourism. While Orbital Reef aims to make space tourism more accessible, while still expensive, advancements in reusable rockets like Blue Origin's New Shepard and SpaceX Starship, the costs are starting to come down. And with the New Glenn just on the horizons here, we could see those alternate contenders also start bringing down the cost for some of the bigger payload missions as well, which will definitely help keep these costs down. So, manufacturing in microgravity. Microgravity enables the production of high-quality materials and products, such as perfect fiber optics and bioprinted organs that are quite difficult or impossible to create here on Earth. So, having microgravity, I know I've done some looking into this before, and crystalline structures, you can create more or less a perfect crystalline structure, or like they mentioned, fiber optic structures, which is super cool. And I just wanted to go back to the space tourism as well. It's not mentioned here, but Orbital Reef, there's another one, and I'm gonna forget the name here, but they have a balloon that goes way, way up into the higher ends of the atmosphere. Not quite it's still suborbital, but it allows for space tourism more or less like, I think it's a kind of hotel / restaurant dinner in space kind of advertisement. It's also a pretty cool experience. Not sure how I'd feel about taking a balloon up to those altitudes, but just something I thought I'd mention that kind of along the same lines here for future of space stations. More of a temporary, short-term, suborbital one, but also pretty cool. So why is the Orbital Reef space station so exciting? Well, Orbital Reef represents a shift from government-driven space exploration to commercial space economy. It could make space more accessible to more people and foster innovation, collaboration at an unprecedented scale. Kind of like what we saw with SpaceX when they started going. Now, a lot more what used to be government contracts are going to the commercial space industry and private industry companies here, which is super exciting. Now, I think with that, I'm not sure if it's still the case, but the International Space Station at one point, they were talking about bringing down in 2030. I'm not sure if the life is extended again or whatnot. I predict that maybe before they decide to disband the ISS, that maybe it'll go up for auction. Otherwise, we might get to see it burn up in the atmosphere in our lifetime as these other space stations become available. And then these private space stations will more or less rent space to government and contractors to perform their experiments there. So what about these expandable habitats? I mentioned Bigelow Aerospace's B330. Well, this is a cool one. So expandable habitats like the Bigelow Aerospace B330, they're designed to maximize living and working space while minimizing the volume and weight needed for launch. These habitats are essentially inflatable modules that expand in space. So how it works, the B330 is launched in a compact state and inflates once in orbit. The outer shell is made from Vectran, a high-strength material that is tougher than Kevlar. Once inflated, it offers a 330 cubic meter interior, about 1/3 the volume of the entire International Space Station. That's where it gets the name B330s from the interior 330 cubic meter interior that we have there. So what are some of the advantages of this? Well, it's lightweight and compact, and by launching in a compressed form, expandable habitats save a lot on those launch costs. Durability, while a multi-layer design provides excellent protection against micrometeoroids and radiation. Comfort, while the B330 offers a large, customizable interior that could dramatically improve the quality of life for astronauts. Another one that is definitely worth taking a look at is this B330 to get kind of more of an image of what it looks like. I've seen some renders, and it definitely would make a very cool and much more comfortable living experience for the astronauts, so definitely worth taking a look at. So these expandable habitats could serve as standalone stations for research or tourism, but modules for larger stations like Orbital Reef, habitats on the Moon or Mars, where launch weight is critical for consideration as well. So there's lots of use cases for these. I'd like to see a combination of the two. Maybe Orbital Reef has some use cases for docking, say, expandable habitats as well, and I think that's what we need, a lot more collaboration across these private industries to really come together and build our next livable habitat in orbit, and obviously elsewhere and beyond. So these same technologies will help us for building habitats on the Moon, Mars, in other orbits around our solar system as we become an interplanetary species, as Elon would say. So let's talk about the Lunar Gateway, a station beyond Earth. So the Lunar Gateway is a NASA-led initiative developed in partnership with international space agencies and commercial companies. So it's planned as a small modular space station that will orbit the Moon, acting as a staging point for lunar exploration and future missions to Mars. So the design and purpose of this is, while the Gateway will be much smaller than the ISS, it is a modular design that allows for gradual expansion. So it'll provide living quarters, science labs, and docking ports for lunar landers and other spacecraft. It'll serve as a refueling station and logistics hub for missions beyond Earth. So why is this exciting? Well, like I mentioned, Mars missions. The Gateway will play a critical role in developing the technologies and strategies needed for human missions to Mars. International collaboration, like we saw with the ISS, the Lunar Gateway is a joint effort between spacefaring nations, symbolizing global cooperation and in space exploration. It's always nice to see that, regardless of politics around the world and nations and that maybe at ends with each other, in the space world, it seems we still like to come together and collaborate for the greater good, I guess, of humans and becoming that interplanetary species and really progressing in the space environment. So just wanted to mention that. I think it's super cool how, regardless of what's going on, we all still seem to come together for space. Now, what about sustainability? By establishing a permanent presence around the Moon, humanity is taking its first steps towards a sustaining off-world economy. Also super exciting, and I'm super pumped to see this in my lifetime. So other concepts that are shaping the future, well, beyond these big projects, there are other exciting concepts that are emerging. Starship and Starship-fueled stations. So SpaceX's Starship could act as both a space station and a vehicle enabling missions to Mars and beyond. What about artificial gravity? So artificial gravity stations, concepts like rotating habitats could simulate gravity, addressing health issues associated with the microgravity environment. What about Mars surface habitats? Well, space stations on Mars could be built using in situ resources like Martian regolith and ice, reducing the need to transport materials from Earth. I have some cool ideas about this, and I've seen some old manufacturing techniques that kind of speak to this as well, and I've had some fun with AI generating some images around this, so maybe I'll share those with you at a later date. So why do these developments matter? Well, the next generation of space stations will enable humanity to live and work in space sustainably. They'll open new opportunities for research, e-commerce, well, I guess not e-commerce, commerce, and even recreation. So they represent humanity's transition from exploring space to inhabiting it. It's super cool to think about that in our lifetime we're gonna have people living, working in space, manufacturing, building things, and it'll become just a regular way of life, kind of how it's been with the ISS, but now at a much greater magnitude, especially with Lunar Gateway opening that door. So super exciting time, and definitely encourage everyone here to follow along with all the other companies if you don't already, like NASA, Blue Origin, SpaceX, Sierra Space, and all those, and really keep track of what's going on. I'll do my best to keep everyone up to date here with what's going on and what the future looks like, but getting some visuals definitely help. I'm a very visual person, so if I had more time, I'd turn these into YouTube videos and give you guys something to look at, but for now, we're gonna stick to these podcast structures. So with that, the future is closer than we think, and as projects like Orbital Reef, B330, and the Lunar Gateway take shape, we're not just reaching for the stars, we're building our homes among them. Yeah, that was a good one. Anyways, space stations are humanity's outposts in the cosmos, bridging the gap between Earth and the stars. They represent our collective ambition and ingenuity, and their legacy will shape the future of exploration, both for us, our kids, grandkids, and future generations. So until next time, everyone, don't forget, stay curious, keep looking up, and I hope you have a great rest of your day. Take care, all.